Imagine you're aboard a research vessel. After years of travel, your destination is finally within reach. For decades, humanity has studied this object from a safe distance. We've measured its pulses, mapped its magnetic field, estimated its mass. But no human has ever seen it with their own eyes. No spacecraft has ever ventured this near. The mission is simple: observe, record, and, if possible, understand. At first, it doesn't look like much. Just another point of light suspended in the darkness. Small, distant, almost insignificant. But hidden within that tiny speck is one of the most extreme objects in the known universe: a neutron star. Millions of years ago, this object was a star, a giant sphere of hydrogen and helium. For millions of years, it fought a constant battle: gravity pulling inward, fusion pushing outward, until one day, the fuel ran out, gravity won, the star collapsed, its core compressed beyond anything we can experience on Earth. Electrons and protons were crushed together. Matter itself changed. What remained was a sphere barely 20 kilometers across, yet containing more mass than our sun. A city-sized object with the weight of a star. This is what happens when gravity pushes matter almost as far as it can go. Any more mass, and the star would have continued collapsing, crossing a final boundary, becoming a black hole. Instead, it remains here, balanced on a knife's edge, a place at the very edge of what physics can sustain, where reality is stretched almost to its breaking point and still holds together. As the ship approaches, something begins to feel wrong. At first, the changes are subtle, easy to dismiss. A star slightly out of place, a familiar pattern that no longer looks quite right. But slowly, the universe starts behaving differently. The neutron star's gravity bends the path of light itself. Stars behind it appear displaced. Background constellations stretch and distort. Space no longer feels flat. It feels curved, as though reality itself is beginning to bend around something hidden from view. Something so extreme that it is starting to bend reality itself. Many neutron stars spin. Some rotate dozens, even hundreds of times every second. As they spin, powerful magnetic fields channel streams of charged particles into enormous beams of radiation. Across the galaxy, these beams sweep through space like cosmic lighthouses. To distant astronomers, they appear as pulses, regular, predictable, almost mechanical. But standing here, their true scale becomes impossible to ignore. Each pulse carries more energy than humanity has generated throughout its entire history. And the neutron star repeats that feat hundreds of times every second, relentlessly, for millions of years. And with every rotation, the neutron star reveals just a fraction of its power. Distance is safety, and safety is rapidly disappearing. The magnetic field surrounding a neutron star is unlike anything found on Earth. It is not simply stronger. It exists on an entirely different scale. Close enough, it could strip electrons from the atoms that make up your body. Matter itself begins to lose its structure. The space around you is no longer empty. It is filled with forces so extreme that survival becomes uncertain. Gravity pulls, magnetic fields twist, radiation floods the darkness. Everything here is being pushed toward a limit far beyond anything life was ever meant to endure. You are no longer approaching a star. You are entering a cosmic storm, one powerful enough to tear matter apart. You are now closer than any human has ever been. For years, this object existed only as data, measurements, equations, radio pulses crossing the galaxy. But now it hangs beneath you, real, silent, almost impossible to believe. A marble of crushed matter, a city-sized remnant of a dead star. Gravity bends the light around it. Time itself flows differently in its presence. Everything about this place exists at the very edge of what physics allows. And yet, from a distance, it appears almost perfect. Smooth, silent, beautiful, the kind of beauty best admired from afar. Black holes represent a point beyond understanding, a place where our descriptions of nature begin to break down. But a neutron star is something different. It is reality pushed to its absolute limit and somehow remaining intact. You came here expecting to find an object. Instead, you found a boundary, a place where reality is stretched to its absolute limit. Any further, and it gives way to something else, a black hole, the unknown. But here, reality still holds, barely. At the edge of possibility, you found something remarkable. Not a black hole, not the end, but the last place reality can go before collapsing into something unknown.